This video is part 3 of my videos designed to help you get ready for organic chemistry, and in this video I'm going to be reviewing Lewis structures. In general chemistry, you learned how to draw Lewis structures for molecules. They look something like this. They're just two-dimensional representations of molecules that show all of the atoms, all of the bonds, and all of the lone pairs. And in general chemistry, you learned a set of steps that you had to follow or rules that you had to follow to come up with the Lewis structure for a molecule. In my previous video, I talked about common bonding patterns for the atoms that we typically see in organic molecules. Because the atoms in organic molecules follow these really common bonding patterns, it makes it really easy for us to draw their Lewis structures without going through all of those steps that we had to use when we were drawing Lewis structures in general chemistry. So what I'm going to do is take these common bonding patterns. Actually, I think I'm just going to take the common bonding patterns for the elements, just showing the single bonds. I'm gonna not copy the ones with the multiple bonds just to save space. I'm gonna take those and I'm gonna stick them over here just so that we have them handy for reference while we're working through these problems. And we're just gonna jump right in and draw some Lewis structures for some organic molecules. Now, before we jump into our first example, I've got a Lewis structure of an organic molecule down here that I wanna talk about a little bit. I'm going to talk about a couple features of this Lewis structure. So first of all, when I'm drawing or looking at a Lewis structure for an organic molecule, I like to talk about what I refer to as the inside of the molecule and then the outside of the molecule. So the inside of the molecule is going to be this connection of atoms that are literally, like, I don't know how else to describe it, on the inside of the molecule. And then the outside will be other atoms that are around the perimeter of the molecule. And if you take a look at this particular example, you'll notice that all of the hydrogen atoms are on the outside of the molecule. The halogen atom is also on the outside of the molecule. The carbons, oxygens, and nitrogens are all on the inside of the molecule. And this is just a general rule for organic molecules. Because hydrogen atoms and halogen atoms are only capable of forming one single bond, those elements can never be on the inside of a molecule. So we could never, for example, we could never put a hydrogen here because hydrogens cannot form two bonds. We could never put a halogen here because halogens can't form four bonds. So our hydrogens and halogens are always going to be on the outer perimeter of our molecules, and the inside of the molecule will always contain our carbons, oxygens, and nitrogens. When I'm drawing a Lewis structure, I like to start by drawing the inside portion of the molecule first. My carbons, my oxygens, and my nitrogens. Once I get that done, then I come back around and add my hydrogens and halogens to the empty spots. So let me show you how this works with our first example. For this molecule, we have 3 carbon atoms, 8 hydrogens, and 1 oxygen. And as I said, I'm going to start by drawing my carbons and my oxygens. Now, just as a quick reminder for the bonding patterns for these elements, carbon likes to form 4 bonds, oxygen likes to form 2 bonds. Now, one of the things that I don't know when I'm drawing this Lewis structure is I don't know how these atoms are technically connected or arranged. I know that I'm going to have 3 carbon atoms in the center of my molecule. I know that each carbon atom likes to form 4 bonds. I'm going to put a second carbon atom here, and that carbon atom also likes to form 4 bonds. And I'm going to put my third carbon atom right here, and that carbon atom also likes to form 4 bonds. And notice that I'm giving 4 bonds to every single one of these carbon atoms because that's its common bonding pattern. And now I'm going to add my oxygen atom, and I'm just going to stick it out here. And oxygen likes to have 2 bonds and 2 lone pairs, so there we go. And what I'm saying, or what I was saying before I started drawing this, was I don't actually know how these 4 atoms are arranged in this molecule. I just chose to draw 3 carbons in a row followed by an oxygen. It could have been a carbon with an oxygen and then 2 more carbons after that. I honestly don't know how it's arranged, and that's really not the purpose of this particular problem. That idea, the actual order of arranging the atoms in a molecule, that is something that you will learn in the organic chem class that you're about to take, and we don't need to review that here. We just need to review drawing Lewis structures that are valid and reasonable. So here are our 4 inner atoms, the 3 carbons and the oxygen. And now what we're going to do is go around the outside perimeter of the molecule and add those 8 hydrogens. And if we've done this correctly, we should have 8 spots for those 8 hydrogens. 6, 7, 8. And that's it. That's all we have to do. That works perfectly. Now, if you're feeling really stressed about the order of the atoms in this molecule, again, we're not really worried about that at this particular time, but we could draw a couple of valid Lewis structures for the formula C3H8O. So there's another valid Lewis structure for C3H8O. Let's move on to our next example. So here we have C3H9N. Remember, don't worry about the don't worry about the hydrogens yet. Let's just start by drawing the inside of our molecule. We have a carbon atom, which likes to form 4 bonds. Let's do our nitrogen next. We have a nitrogen atom, and looking at nitrogen's common bonding pattern, nitrogen likes to form 3 bonds with a lone pair. And then let's give our second carbon atom. Carbon likes to form 4 bonds, and our third carbon atom with 4 bonds, looking like that, looks good. And then now let's fill in those 9 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, if you're hung up on what's the correct order of these atoms, there isn't one. There are multiple correct orders of the atoms for these Lewis structures. We're just trying to propose a Lewis structure that is valid. Okay, so moving on, let's make these examples a little bit trickier. Now we have C3H6O. Again, start by focusing on our carbons and our oxygens. We've actually already done 3 carbons and 1 oxygen. We already kind of have an idea of how that's going to work. So we've got 1 carbon atom number 2, carbon atom number 3, oxygen, which likes to form 2 bonds, and 2 lone pairs. And now we are going to fill in our 6 hydrogen atoms. 1, 2, 3, 4, 5, 6. Now here we've got a little bit of a situation because we don't have enough hydrogen atoms to fill in all of these empty spots on this particular molecule. Don't be stressed out by that. When we run into this situation where we don't quite have enough hydrogen atoms to fill everything in, that just simply means that one of our our inner atoms, one of our carbons or our oxygen, is forming a multiple bond. So remember that carbon atoms can have double bonds or even triple bonds. The oxygen atom can have a double bond as well. So we just need to make a multiple bond somewhere in this molecule. And this is where things there's going to be tons of options of how we could go about doing this, tons of options. I'm just going to I'm just going to put a double bond in between those 2 carbon atoms right there. That's just what I chose. If you're stressing out, like, why did you choose to do that? I don't know. That's just what I chose to do. I'm going to put a double bond right there. This is still valid. This carbon atom still has 1, 2, 3, 4 bonds. This carbon atom still has 1, 2, 3, 4 bonds. Everything looks good. And now we have 1, 2, 3, 4, 5, 6 spots for hydrogen atoms. So that's where they're going to go. Now, that may have felt really arbitrary to you because when we draw Lewis structures in Gen Chem, we have really specific rules about what to do. And here in this case, I'm just saying, just do whatever you feel like. Put a double bond somewhere. What the heck? Why not? But that's how it works in organic chemistry. And again, there are many correct versions of this particular molecule that would satisfy this C3H6O formula. So maybe another option we could draw here. See if we could put a double bond there like that. That would have worked as well. 3 carbons, 1 oxygen, 1, 2, 3, 4, 5, 6 hydrogens. So we've got a lot of different options about how we could draw these Lewis structures. And again, when you're actually in organic chemistry, you are going to cover how to know which of these 2 molecules you're supposed to draw. One more example, we have 3 carbon atoms. So let's start with those. Carbon number 1, carbon number 2, carbon number 3. And we have 4 hydrogen atoms, 1, 2, 3, 4. So we can see that we have fewer hydrogen atoms than we need to fill in the perimeter of this molecule. And again, that means that we just need to make multiple bonds. So we can start by putting a double bond right here between those 2 carbon atoms. And now we have carbon atom number 1 with 4 bonds, carbon atom number 2 with 4 bonds, carbon atom number 3 with 4 bonds. They all look good. And filling in the hydrogens, 1, 2, 3, 4. We still have to work on this structure. We still have too many spaces, not enough hydrogens. So we're going to have to make another multiple bond. We could make another double bond if we wanted. We could put another double bond over here if we wanted, or we could make a triple bond, which sounds really exciting. So let's put a triple bond right there. Each carbon atom has 4 bonds, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And now we have room for 4 hydrogen atoms.